Now, after you have learned the tangent and cotangent function, how to sketch the graphs of tangent or cotangent curves, I want to ask you, do we talk about amplitude for tangent or cotangent? We don't ask, we don't even say amplitude, right? We do not, because the tangent is unbounded, or the cotangent. They're both unbounded. Let's do a sketch of the tangent. The tangent curve, you see, there's a vertical asymptote, and this is one period of tangent, right? Increasing, but never touch the vertical asymptotes. Yes, one period. And note that the one period from negative half of pi to positive half of pi. So this is a curve tangent x, but this pattern will repeat. So I can draw another period. So I can, yeah, I can draw another period of tangent. So this increasing. So as you can see, this interval, the length of this interval is pi, from negative half of pi to positive half of pi. So this is half of pi and plus half of pi. So the period is pi. The interval has a length of pi. So that is the period, because each interval of length pi, the tangent function will repeat. You see the pattern will repeat itself. So this is one period and another period. So each interval has a length pi. But why this curve? We do not talk about amplitude, because this curve is unbounded. You see, it goes all the way to infinity and go all the way to negative infinity, can be as big as possible, right? So the tangent value is not bounded. Therefore, we do not talk about amplitude. Amplitude basically is the largest displacement, right, from a center line. But although there is a center line here in the middle, but there's no largest like displacement from the center line. So in that sense, but we can ask a period, just like tangent function has a period. But what about the variations of tangent function? How can we determine the period or phase shift? So let me give you a few functions. So here is a function. I can do the 3 tangent 5x. Yeah, then what is the period? Period of this function. But we know the period of a basic tangent function, right? If we have a tangent x, if I just look at the basic tangent function, tangent x has a period of pi. We just looked at a tangent x. So the period of tangent x is pi. But now this is tangent of 5x. So the period will be affected by this number 5. So the period of the given function, this function will be pi over 5. So fifth of pi. It's smaller, you see, with a number here 5, and the period is pi over 5. So you notice the larger this number, the smaller the period. So let me give you another function. So this time I will use tangent 1/3 x. So what is the period of this function? So period, again, for basic tangent function, we know the period is pi. But this is not a basic tangent function because of this 1/3. Right, 1/3 times x. So, and still we use this number, we can determine the period of this given function. So pi over this number, 1/3. Pi over this number means, okay, pi times the reciprocal of 1/3. So pi times 3, that's the 3 pi. Yeah, so we just see that for this function, its period is 3 pi. And same thing for the cotangent. So if I write a cotangent function, suppose I have a cotangent x, or let's say 2x minus 10. Yeah. So what is the period of this function? The period is equal to, because basic cotangent function has a period pi, right? But this one is not. So we should use pi over this number. So it's pi over 2. So half of pi is the period of the given function. What about phase shift? Can we determine its phase shift? Yes. So we can continue to determine the phase shift of this given function. Phase shift, if we write this function, let's take a look at the function. If I write the function into this form, I factor out the 2, then we can see better. Then the x variable minus 5, right? If I factor out the 2. So then we notice the phase shift here, x minus number 5. 5 is the phase shift. So the phase shift is 5. Yeah, phase shift is 5. So let's compare this with a curve. What does that mean? Phase shift is 5. That is, if I compare with this cotangent 2x, means when phase shift is 0, right? When phase shift is 0, then I have cotangent 2x. So this curve, if I can sketch that curve, then I should shift this curve. So how do I shift? So I shift this curve once I sketch it. I shift it 5 units to the right. 5 units to the right. To get what? To get this curve. Yeah. So the number 5 means if you do shift of 5 units of this one, then you will be able to get this. So that is the meaning of the number 5. Okay, so this is how to determine the phase shift. So of course, we can do another one. So let's write a cotangent function. Cotangent 3x minus pi. So let's, or plus pi, let's make it a plus sign. So tell me the period and phase shift. So first, period can be quickly determined by pi over 3, right? So I just look for the coefficient in front of x. Yeah, so that number will determine the period of the given cotangent function. Yeah, pi over 3. And phase shift. Phase shift is, okay, so then we will need to rewrite this function so we can see better. So cotangent, if I factor out 3, then what is left? X plus pi third, right? So that after a factor of 3, you can always double check. You see 3x, we get this, right? 3 times 1/3 of pi, you get pi. Yeah. So you can quickly do a double check that after you factor. So this, you see, this means a shift, horizontal shift to the left-hand side to get this curve. Which curve? So let's think when the phase shift is 0, that means when the phase shift is 0, right? That will be cotangent 3x. Cotangent 3x. So this curve, if we do a shift of pi over 3 units to the left, So you shift this one, cotangent 3x, this many units to the left, then you will get the desired curve. Yeah, so the phase shift is actually negative pi over 3. Yeah, it's a negative pi over 3. If you remember the video I talked about, but for the sinusoidal functions, you can also try to rewrite this curve into the standard form. So you can easily determine. So as long as you write this, because when you see a plus, then the standard form is a minus number, right? 3x minus what? Plus means minus negative. Yeah, so this number is the phase shift. So the phase shift is the negative pi over 3. Yeah, so the reason I write that is for you to recognize the standard form of tangent or cotangent. So if we think of the standard form of the cotangent with a number here and cotangent with maybe a number inside, and then x minus c, and then plus some constant, right? This A, B, C, D. So this A, B, C, D. See these numbers, and they tell, then this number is called phase shift. That means you can, as long as you write it into this form, then you can decide the phase shift. So when we write this into minus negative, we know the phase shift is negative pi over 3. Okay, that's all for tangent and cotangent variations and how to determine period of a given function and phase shift of a function. So I want you to keep in mind the standard form, because using the standard form, it's very easy to determine the phase shift. For example, right there, this right here, yeah. So I also want to remind you that when it's not written in the standard form, you must rewrite it, right? For example, here, the 3 must be factored. So your x variable is now standing out with x plus a number or x minus a number, no matter what it is, to show the phase shift more explicitly. Okay, that's all.